Every city in Rome is a copy of the previous one. And that is precisely why the empire worked. The Romans did not believe in uniqueness when it came to governing territories or building settlements. They believed in a system that allowed them to build a civilization in the middle of a desert or dense forest in record time. It was not an architectural impulse, but a well-oiled industrial conveyor belt that had been running smoothly for centuries. We are used to looking at ruins as works of art, but their creators thought in terms of factories. Modularity, standardization, and strict regulations replace creative inspiration. Watch the video to the end, and you will learn what one simple detail allowed the Romans to feel at home in both Britain and Syria. What if I told you that the greatest empire in history was held together by two crossed wooden sticks? Before the first stone was laid in a new place, a man would arrive with a tool that looked like a primitive cross. This tool was called a gramma, and it was the main weapon of Roman expansion, more important than the sword. The surveyor did not just look at the terrain, he imposed a strict mathematical grid on the chaos of nature. His task was to find perfect right angles where they had never existed before. The gramma was a pole with a crossbar fixed at the top, from the ends of which plumb lines hung. The surveyor positioned it so that the plumb lines were aligned with a selected landmark on the horizon. An assistant ran into the distance with a stake, and at the surveyor's command, drove it into the ground. Thus was born the first line that cut through the wild space, subjecting it to Roman will. This action was almost a religious act, transforming foreign land into part of an orderly world. They had no sophisticated optical instruments, only gravity and the human eye. An error of even 1 degree at the beginning of the journey could lead to a catastrophic shift in the streets a kilometer away. Therefore, surveyors were people with exceptional vision and a steady hand who had undergone long training. They did not draw maps on paper, they drew them directly on the landscape, changing it forever. Every bump, tree, or stream that interfered with a straight line had to be removed. The marking process always began at the central point of the future city, which was determined by priests. 4 rays diverged from this point, dividing the world into understandable sectors. It resembled a crosshair aimed at an empty space that would soon be filled with life. The Romans did not adapt to the terrain. They forced the terrain to adapt to their drawings. Mountains were torn down and ravines were filled in to preserve the perfect geometry of the plan. This approach completely ruled out improvisation in the early stages of construction. No one could build a house where they liked or lay out a curved street. Everything was subject to a single plan, which was approved thousands of kilometers away from the construction site. Such rigidity ensured that any legion that came here later would be able to find their way around instantly. The city became a comprehensible mechanism, the instructions for which were in everyone's head. Standardization began right here in the field, under the scorching sun or pouring rain. The surveyor divided the territory into equal square plots called centuria. Each square had a fixed size and clear boundaries marked by boundary stones. This made it possible to instantly distribute land among veterans or colonists without disputes or lengthy measurements. Land became a commodity packaged in standard containers. Even centuries later, modern roads in Europe often follow the same lines that were once measured by people with thunder. Satellite images show this grid emerging through modern fields and cities. This is the legacy of the most ambitious operation to reshape the Earth's surface in human history. The Romans did not just build cities, they formatted space like a hard drive. The tool was simple, but it required absolute discipline and faith in the correctness of straight lines. The barbarians who watched this process could not understand the meaning of these manipulations with sticks and ropes. For them, a city was a jumble of huts. For the Romans, it was an equation embodied in stone. It was this intellectual gap that made the Roman conquest irreversible. Once the grid was laid out, the builders got to work, but the plan already existed in the form of pegs in the ground. This plan was universal. It didn't matter whether the city was being built in the sands of Africa or in the mists of Albion. This allowed the same engineering solutions to be used in completely different climatic conditions. Rome exported not just architecture, but the very principle of organizing life. Do you think our lives would be easier if modern cities were built according to the same strict and uniform standards? Write your opinion in the comments. Are you ready to learn the truth about why it was impossible to get lost in a Roman city? The secret lay in the two main arteries that pierce the settlement through and through. The first street, running strictly north to south, was called the Cardo Maximus. The second, crossing it at a right angle from east to west, was called the Decumanus Maximus. It was not just an intersection, it was a skeleton on which everything else was strung. These two streets were the widest and paved with the best stone. They served as the main transport corridors along which goods, troops, and processions moved. The width of the Cardo could reach 12 meters, which allowed two oncoming carts to pass each other. Colonnades lined them, providing shade for pedestrians and concealing the entrances to shops. The intersection of the Cardo and Decumanus was the geographical and conceptual center of the city. An empty space was always left here, which was not built up with housing. This place was intended to be the heart of public life, which we will discuss later. Addresses and distances to any point within the city walls were measured from this intersection. All other streets were laid out parallel to these two axes, forming a perfectly even grid of blocks. The blocks, or insulae, were of standard size, which simplified planning. The architect did not need to calculate the area of the site each time. He simply took a ready-made module and placed it in the desired cell of this giant table. This layout ensured excellent ventilation of the city. The winds blowing along the straight streets blew away dust and smoke from the hearths, preventing smog from stagnating. The Romans took the windrows into account even at the stage of the surveyor's work with the thunder. It was a primitive but effective climate control system for the entire city. The orientation of the streets according to the cardinal points also had practical significance for insulation. The sun illuminated different sides of buildings at different times of the day, preventing them from overheating. In the southern provinces, the streets could be made narrower so that the walls of the houses provided more shade. In the northern provinces, they were made wider to catch every ray of the rare sun. This grid made the city transparent to the authorities and convenient for the police. Patrols could see hundreds of meters ahead without fear of ambushes around corners. Straight lines left no room for dark alleys where criminals could hide. Order and architecture dictated order in public life. For merchants and visitors, this system was incredibly convenient. A person arriving from Rome and Alexandria or Lugdunum immediately understood how the city was organized. They did not need to ask for directions to the market or temple. They intuitively knew that by moving along the Decumanus, they would inevitably reach the center. Scalability was another huge advantage of the modular system. If the city grew, the grid was simply extended further into the countryside, adding new neighborhoods. There was no need to redesign the old center or change the structure of the streets. The city grew like a crystal, retaining its original shape and logic. But even the most ideal street grid is useless if it does not have clear boundaries. In the next chapter, you will learn what invisible line was more frightening to the Romans than any stone wall. What I am about to show you was not just construction, but a magical ritual. Before erecting stone walls, the Romans drew a sacred boundary around the city, the pomerium. This was done with a bronze plow pulled by a white bull and a white cow. The priest who controlled the plow made sure that the furrows fell inward, symbolizing the wealth that would accumulate in the city. The pomerium was an invisible spiritual wall separating order from chaos, civil peace from the military zone. Inside this line, it was forbidden to carry weapons or bury the dead. Even the highest magistrates, who had military power, became mere civil servants when they crossed the pomerium. It was a space of absolute law, protected by the city gods. Physical walls were erected slightly away from this sacred line, but repeated its outline. The wall was not only a fortification, but also a psychological barrier. It clearly stated, this is where wild nature ends and civilization begins. For the inhabitants of antiquity, the world outside the walls was hostile and unpredictable. The construction of walls was a standardized process, as was everything else in Rome. Formwork was used, into which concrete was poured or rubble was poured, and the outside was faced with hewn stone. The thickness of the walls was calculated so that two fully armed warriors could walk freely on top of them. Towers were placed at a distance of an arrow's flight from each other so as not to leave any dead zones. The city gates were always located at the exits of the Cardo and Decumanus. These were not just passageways, but triumphal arches demonstrating the power and wealth of the city. The gates often had double passages, one for entry and one for exit to avoid traffic jams. Guard rooms and toll collection rooms were set up above the gates. Interestingly, in places where gates were planned, a priest would lift the plow and interrupt the furrow. It was believed that it was forbidden to cross the continuous sacred line or carry goods across it. Therefore, the gates were not technically part of the sacred perimeter of the city. This was a clever loophole in religious law that allowed the city to breathe and trade. The walls also served as a customs barrier. All goods imported into the city were taxed at the gates. This turned the city wall into an instrument of economic policy. Control of entry and exit was total, and not a single sack of grain could slip through unnoticed. Over time, as the empire expanded and external threats receded, the walls of many cities became a mere formality. Settlements spread beyond them, sprawling into suburbs along the roads. But in the early days, walls were an essential attribute, without which a city could not be considered a city. They were its skin, protecting the delicate body of civilization. The quality of the masonry was such that many sections of these walls still stand today. The Romans built with a margin of strength for millennia, not skimping on materials. For them, the wall was the face of the city, the first thing a traveler saw when approaching the settlement. It was meant to inspire respect and fear. If you enjoy learning about the hidden meanings of ancient architecture, be sure to like this video. Guess what happened next when the grid of streets and walls was ready? The builders began to create the Forum, the main public space. The Forum was always located at the intersection of the Cardo and Decumanus, usually covering an area of several blocks. It was a standard set of buildings that could be found in any city, from Britain to Africa. The Forum was a rectangular square paved with slabs and surrounded by covered colonnades. It was a place where politics, religion, and commerce converged. There was none of the chaos of an Eastern bazaar. Everything was subject to a strict hierarchy and order. Each building had its own specific place and purpose in the urban system. At one end of the square always stood the main temple, dedicated to the Capitoline Triad, Jupiter, Juno, and Minerva. The temple stood on a high podium, dominating the space and reminding everyone of Rome's divine patronage. It was an ideological anchor connecting the provincial city with the distant capital. In front of the temple was an altar for public sacrifices. At the opposite end or to the side, a basilica was built. Do not confuse this with a Christian church. In Rome, a basilica was a business center and a court of law. It was a huge covered building with rows of columns inside where deals were made and justice was administered. People sought refuge here from the heat or rain, discussing the latest news and grain prices. Around the perimeter of the square were tabernae, shops, exchange offices, and administrative offices. The curia, where the city council, the local equivalent of the Senate, held its meetings, was also located here. All these buildings formed a closed circuit, turning the square into a huge open-air hall. The Forum was the stage on which the life of the city was played out. Statues of emperors and local benefactors were often placed in the center of the square. It was a kind of honor board carved in marble and bronze. Every citizen passing through the Forum saw the faces of those to whom he owed his well-being. It worked as a powerful propaganda tool for loyalty and patriotism. The standardization of forms was ridiculous. Archaeologists find absolutely identical plans for squares in cities separated by thousands of kilometers. This made it possible to send architects from the center who simply adapted a standard design to the local area. Cities received a proven and working turnkey solution. The Forum was a place where residents felt like citizens. Decrees were announced, elections were held, and holidays were celebrated here. The acoustics of the square were designed so that the speaker's voice could be heard by a large number of people. It was a technology for controlling mass consciousness through architecture. But stone and marble are dead matter until life is breathed into them, and life is impossible without water. In the next chapter, you will learn how the Romans made rivers flow across the sky. Water was the lifeblood of the Roman city, and its delivery was an engineering feat. Aqueducts, those majestic stone bridges, were only the visible part of a huge system. Most of the water supply ran underground, in tunnels and pipes, hidden from view. Water flowed into the city for tens of kilometers, obeying only the force of gravity. Engineers calculated the slope with fantastic precision, just a few centimeters per kilometer of travel. This required the precision work of surveyors, who used primitive but effective tools such as thunderbolts and horribats. If the slope was too steep, the water would erode the bottom of the canal. If it was too gentle, it would simply stagnate and turn into a swamp. To maintain this perfect balance, builders had to cut through mountains and build arches over deep gorges. It was a true victory of mathematics over geography. The construction of such structures took decades and required enormous resources. Huge stone blocks were hewn by hand and fitted together without the use of mortar. The entire path of the water was carefully thought out so that it would not lose speed or overflow. Every meter of the aqueduct was the result of complex calculations that modern engineers are still studying today. The water entered the city through a special reservoir called a castellum aquae, or water distribution tower. It was a massive brick building, inside which the flow slowed down and was cleaned of sand. From there, it was distributed in three main directions: to public fountains, public baths, and private homes. Each direction had its own level of access and payment system. Priority was always given to public needs so that every citizen had access to drinking water. If the water level in the reservoir fell due to drought, private villa owners were the first to be disconnected from the system. This ensured that ordinary people would not be left without water during the hottest period. Only after the public pools were filled was the surplus sent to the private gardens of the wealthy. The pipes for distributing water were made of lead, fired ceramics, or even wood. Lead pipes, called fistulae, had standard diameters, which made it easy to connect them and quickly replace damaged sections. Many of these pipes were stamped with the manufacturer's mark in the name of the customer, which served as a kind of quality guarantee. This allowed officials to know exactly who was responsible for the condition of a particular section of the water supply system. The Romans knew about the dangers of lead, and some doctors of the time wrote about it in their works. However, they believed that running water moved too quickly and simply did not have time to become saturated with the dangerous poison. In addition, limescale quickly formed on the walls of the pipes, which served as a natural protective layer. Therefore, the problem of mass lead poisoning in ancient times was not as acute as is commonly believed. Fountains were so common on the streets that residents did not have to walk more than 50 meters for fresh water. They operated around the clock, creating a constant sound of running water, which became the background noise of Roman life. The excess water from these fountains was not wasted but was used for urban hygiene. This constant flow of water washed all the dust and dirt from the pavements straight into the city's sewage system. The sewer system, or the famous Great Cloaca in Rome, was no less complex than the aqueduct itself. A huge network of tunnels ran under the streets, through which sewage was carried far beyond the city limits. The main collectors were so wide that a hay cart could easily pass through them. This engineering marvel required constant supervision and regular cleaning of silt and debris. State slaves and convicted criminals were responsible for maintaining this huge underground system. The work was hard and dangerous, but without it, the city would quickly suffocate in its own waste. The vaults of the cloaca were so sturdy that they could support the weight of entire neighborhoods above them. Even after 2,000 years, some parts of this system continue to function. The presence of a flowing sewer system radically changed the entire sanitary situation in a city of many thousands. There were no open cesspools in Roman neighborhoods that poisoned the soil and air, as was later the case in medieval Europe. All waste products were instantly carried away by a powerful stream of water into the Tiber River. It was invisible to the eye, but it was a critically important protection for the population against terrible diseases. Public toilets, called latrines, were also connected to this flushing system. These were spacious and well-lit rooms with marble seats where people did more than just relieve themselves. The latrines were a place for socializing, where citizens discussed the latest news and gossip. Technical water constantly flowed under the seats, carrying away everything unnecessary, and a trough with clean water for washing ran along the floor. The water supply and sewage system was so valuable that it required the utmost care. Special high-ranking officials, water curators, personally monitored the condition of all the pipes and aqueducts in the empire. They hired entire teams of technicians to patrol the water lines and look for damage. One of their main tasks was to combat illegal taps, through which city water was stolen. Water theft in those days was considered a serious crime against the entire urban community. Those who tried to secretly connect to the aqueduct to irrigate their fields were subject to huge fines. The Romans understood that their civilization literally depended on water, and they protected its resources accordingly. Violation of the rules for using the water supply could lead to the loss of civil rights. The Romans understood that their civilization depended on water and protected it accordingly. Water gave life, but walls and aqueducts had to be built from something. The next chapter will reveal the secret of the material that allowed Rome to stand forever. What if I told you that we have only recently unraveled the secret of Roman concrete? The Romans invented a material that not only hardened, but also became stronger over time, even when submerged in water. This material, opus cementicum, revolutionized construction, making it possible to abandon the use of expensive hewn stone. It transformed construction from the slow craft of stonemasons into a rapid industrial process of pouring molds. The secret ingredient of this miracle material was pozzolan, a special volcanic ash that was mined near Vesuvius. When mixed with lime and seawater, it underwent a complex chemical reaction. As a result, incredibly strong crystalline bonds formed inside the concrete, which did not break down for centuries. It was a unique discovery that was thousands of years ahead of its time. Modern concrete deteriorates over time due to exposure to salt water, but Roman concrete only became stronger. This amazing property made it possible to build giant seaports, breakwaters, and bridges, many of which still stand today. The chemical composition of pozzolan allowed concrete to set even in the complete absence of air. This meant that the Romans could pour the foundations of buildings directly into the sea. Concrete technology completely freed architects from the former dictatorship of straight lines and heavy columns. Now builders had the opportunity to create huge domes, graceful arches, and high vaults. This made it possible to cover gigantic public spaces without using a multitude of internal supports. Previously, such halls were simply impossible due to the limited length of wooden beams. The Pantheon in Rome is the best example of this, as its concrete dome remains the largest unreinforced structure in the world. The thickness of the temple walls is calculated to withstand the enormous pressure of this vault. Liquid stone took on absolutely any shape that an engineer's bold imagination could come up with. Concrete allowed Rome to acquire its unique appearance with its huge spaces, but concrete was only the inner filling of the walls, their strong skeleton. On the outside, it was usually faced with neat brick or natural stone, and here too, complete state standardization reigned. Roman brick was very different from ours. It was flat and quite wide. It most resembled modern thick tiles, which simplified the laying process. The dimensions of the bricks were strictly regulated by law, which allowed architects to easily calculate the required amount of material. Brick production was streamlined and resembled modern industry. Each product was often stamped with the mark of the brick factory, indicating the year of manufacture and the name of the workshop owner. This allowed for strict control over product quality and quick identification of those responsible for defects. Huge batches of finished building materials were transported by river and sea on special barges, supplying construction sites throughout the great empire. Thanks to standardization, bricks from one province were perfectly suited for buildings in another. This created a unified architectural style from Britain to Africa. Construction became predictable and manageable from a single center. Concrete and brick construction did not require most workers to be highly skilled. To erect a huge building, all that was needed was one talented foreman and hundreds of unskilled slaves. They simply mixed mortar, carried heavy stones, and poured the mixture into prepared wooden forms. This significantly reduced the cost of labor and greatly accelerated the process of building new cities. Thanks to this technology, new buildings in Rome literally sprang up like mushrooms after a warm rain. The city was able to recover from a fire in a matter of years, filling empty spaces with sturdy concrete boxes. This was the first example of mass standardized construction in history. The strength of such buildings allowed them to serve many generations of citizens. The walls were most often erected using the proven method of the so-called layered cake. The craftsmen laid out two parallel rows of brick cladding, which served as permanent formwork. The space between them was filled with concrete mixed with crushed stone and fragments of old ceramics. The result was a monolithic and extremely stable structure that was almost impossible to destroy. Even if the enemy knocked out the outer bricks during the war, the powerful concrete core continued to bear the entire load of the building. Such a wall was resistant to fire, moisture, and even small earthquakes. The strength of Roman concrete only increased over time, turning buildings into artificial rocks. That is why we can still see ruins that have not crumbled to dust in 2 millennia. This revolutionary technology allowed Rome to build multi-story buildings on a massive scale for the first time in history. The height of structures was no longer limited by the weight of stone blocks or the length of wooden beams. Concrete floors between stories were reliable and, most importantly, fireproof. Cities began to grow actively upwards, effectively saving very expensive land inside the fortress walls. The use of available local materials was another important principle of Roman engineers. If volcanic ash was not available nearby, crushed brick or fine ceramics were used. The Romans were able to masterfully adapt their recipes to any geology while preserving the essence of the technology. It was an amazing flexibility and resourcefulness within a very rigid state standard. Now that we have reliable walls and floors, we need to understand where ordinary people lived. In the next chapter, you will learn why Roman apartments were so similar to modern human dwellings. Insulae were the name given to the multi-story residential buildings that made up the bulk of the Roman city's buildings. They were the direct ancestors of modern apartment buildings, where a huge number of people lived in a limited space. The rich lived in mansions called domus, but 90% of the population huddled in these concrete boxes. An insula could reach 5 or 6 stories in height, which was considered a skyscraper in ancient times. The first floors of insulae were always used for commercial purposes. They housed shops, taverns, and workshops with doors opening directly onto the street. Shop owners often lived there, in small rooms above their businesses, on mezzanines. This created a lively and noisy atmosphere at eye level for passersby. The higher the tenant climbed, the worse the conditions and the cheaper the rent. The second floors could have decent apartments with several rooms and even balconies. But under the roof, on the 5th floor, the poor huddled in tiny cells. It was hot in summer, cold in winter, and the roof constantly leaked. The insulae had no running water or sewage systems on the upper floors. Water had to be carried in buckets from a street fountain, and chamber pots were taken to public toilets, or, to be honest, thrown out of the window. This created the very specific smell of an ancient metropolis that is not mentioned in textbooks. Fires were the main scourge of such houses. Wooden floors, open fires, and oil lamps posed a constant threat. If the lower floor caught fire, the residents of the upper floors had virtually no chance of escape. Therefore, Emperor Augustus even introduced restrictions on the height of buildings in order to reduce the risks in some way. Insulae were built in blocks, often with a common courtyard, onto which the windows of kitchens and corridors opened. This courtyard was the only source of light and air for the interior rooms. Here, laundry was dried, children played, and neighbors gossiped. There was no privacy in such a life. The walls were thin, and everyone knew everything about their neighbors' lives. Despite the cramped conditions, it was affordable housing. Standardized layouts allowed them to be built quickly and cheaply. Real estate speculators made huge fortunes by renting out rooms in such houses. They often skimped on materials, and the insulae collapsed, burying the residents beneath them. Externally, insulae were often plastered and painted in bright colors. The lower floors could be decorated with frescoes or mosaics. The Romans loved visual richness, and even a simple apartment building had to look dignified. The street was a showcase, and the facades were kept in good order. The contrast between the luxury of public buildings and the poverty of the upper floors of insulae was striking. A citizen could spend the day in marble baths or in the Forum, and then come home to a cramped little room at night. The city provided excellent service on the outside, but minimal comfort inside the home. Such dense development formed a special type of urban society. People spent most of their time outside their homes, in the streets and squares. The home was just a place to sleep. All real life took place in public spaces, which were an extension of the apartment. The baths were not just baths, they were palaces for the people, accessible to everyone for a pittance. The Romans turned hygiene into a cult and mass entertainment. In every city, even the smallest, baths were built according to a standard design. It was a standardized complex of services: sports, education, communication, and washing all in one place. The construction of the baths was a complex engineering solution. Under the floor was a hypocaust system, heating with hot air. Slaves stoked the furnaces outside, and the hot smoke and air passed through cavities under the floor and in the walls, heating the rooms. It was often only possible to walk on the floor in special wooden shoes. It was so hot. Visitors passed through a strict sequence of rooms with different temperatures. First, the apodicterium, changing room, then the tepidarium, warm room for warming up, the caldarium, hot steam room with a hot pool, and finally the frigidarium, a cold room with a pool for cooling off. This route was the same everywhere, from Londinium to Carthage. Soap, as we understand it, was not used in the baths. The body was rubbed with olive oil, and then the dirt was scraped off along with the oil using a special metal scraper called a strigil. This was a procedure that friends or slave bath attendants often performed on each other. Cleanliness was achieved mechanically. In addition to washing, the baths had palaestrae, inner courtyards for sports. Here people wrestled, lifted weights, and played ball. After physical exercise, they went to steam. There were also libraries, poetry reading rooms, and even small food stalls. You could spend the whole day here. The baths were a great equalizer. Here, a senator and a simple craftsman were equal, at least in their nakedness. Of course, the rich came with their retinue of slaves, but the water and steam were the same for everyone. This relieved social tension and united citizens. The water in the baths was constantly changing, thanks to those very aqueducts. Used water from the pools was used to flush the toilets adjacent to the baths. The Romans were masters of water recycling, using every liter as efficiently as possible. The architecture of the baths was impressive in scale. Huge vaulted ceilings, mosaic floors, statues of gods and heroes. Even a poor man could feel like part of a great empire when surrounded by such splendor. The authorities cared for the bodies of their subjects, and the subjects appreciated it. The construction of baths was often financed by private individuals who wanted to be elected to office. It was the best way to buy the love of voters, to give the city a bathhouse or make admission free for a month. Political corruption worked for the benefit of public hygiene. The baths were a place where deals were made and conspiracies were discussed. The noise of water and steam created the perfect cover for confidential conversations. The city washed, healed, and conducted its business in one place, built to a single standard. Roman roads were the backbone of the empire's entire manufacturing structure. They were not just well-trodden paths, but multi-layered engineering structures designed to last for centuries. The roads allowed legions to be moved at incredible speed, but they also served as channels for goods, ideas, and standards. Thanks to this network, the emperor's orders reached the farthest corners of the empire in the shortest possible time. The construction of each road resembled a layer cake up to a meter or more in depth. At the very bottom was a layer of large, uncut stones, which served as a foundation and excellent drainage. Above this were layers of fine gravel, crushed stone, and sand, which were often mixed with lime mortar for strength. At the very top, builders laid massive stone slabs that were tightly fitted together. The road always had a characteristic convex profile so that rainwater would not remain on the roadway. All excess moisture immediately drained to the shoulders, where deep drainage ditches had been dug in advance. This technical solution allowed the roads to remain passable even after the heaviest downpours. Thanks to such foresight, Roman roads did not turn into impassable mud. Straightness was the main principle in the design of new routes. Roman engineers preferred to cut through a hill or build a high embankment across a swamp rather than make a long detour. They used special tools to level the route according to the stars or the horizon. This persistence saved travel time, which was critical for state mail couriers in the army. In the Roman view, a straight road was the shortest and most reliable way to convey the will of the center to the periphery. Winding paths were considered the lot of barbarians, incapable of subjugating nature. Therefore, Roman highways literally cut through space, ignoring any natural obstacles. This clearly demonstrated the power and steadfastness of imperial authority. Massive milestone stones stood along the roads every mile, serving as ancient navigators. These pillars indicated the exact distance to the nearest large city and the name of the reigning emperor. At any point during their journey, travelers knew exactly where they were and how far they still had to go. The presence of such markings significantly reduced the fear of the vast and deserted spaces of the empire. Along all the main routes, there was a well-organized state system of post stations called mansio. Here, official couriers could change tired horses, get hot food, and spend the night in peace under guard. The distance between these stations was strictly calculated to cover one standard day's journey. It was the first regular transport network in world history with a guaranteed set of services. Roads were also a powerful tool for standardizing culture and everyday life. It was along them that new fashions, the Latin language, and common religious rites spread throughout the provinces. A city located on a busy trade route inevitably adopted Roman customs much faster than any remote village. The road brought goods from all over the world, making life in Gaul similar to life in Italy. These grandiose structures were built mainly by ordinary legionaries. In peacetime, the army never sat idle, but became the world's largest construction corporation. A soldier with a pickaxe and shovel in his hands was as important to the state as a soldier with a short sword. This practice allowed the troops to stay in excellent physical shape and develop the country's infrastructure at the same time. Road maps of that time, such as the famous Pitangera table, were schematic graphs. They were in many ways similar to modern subway maps in large cities. There was no strict adherence to geographical scale. Only the sequence of stations and the distances between them were indicated. For the Romans, it was not the exact location on the map that was important, but the practical question of how to get to their destination faster. These roads became a reliable foundation for the development of all of medieval and even modern Europe. Many of today's highways lie directly on top of the very stones laid by Roman soldiers. The great empire has long since disappeared from the political map of the world, but its engineering skeleton remains intact. It continues to guide the movement of millions of people and tons of goods along the same routes. Ultimately, all these technical solutions, surveying instruments, concrete, and street grids, served a single purpose. They worked to create the ideal Roman citizen. The city functioned as a huge factory for remelting a wide variety of tribes and peoples into a single civic nation. A person who grew up surrounded by perfectly straight lines and standard buildings began to think in a completely different way. A barbarian accustomed to the chaos of his village upon arriving in Rome saw the power of iron order. Gradually, this visual unity changed a person's inner world, making them part of a large system. Arriving in any city of the empire, even the most distant, a resident would see the same painfully familiar forms. The central forum, city temple, baths, and amphitheater were always in their usual places. This uniformity created a powerful sense of one's own safe space. The empire became a home for people not because it was particularly kind to them. It was a home because it remained predictable, understandable, and logical in every detail. Wherever a Roman found himself, he always knew how life worked in that place. The standardization of life significantly reduced the overall cognitive load on each individual. Merchants did not need to relearn the rules of trade or measures of weight in every new city on their way. A judge did not need to invent new laws every time to resolve disputes between neighbors. Even a builder did not need to reinvent the wheel or the composition of mortar for walls. All the enormous energy that could have been spent on solving minor everyday problems was now directed toward development. The free resources of society were used for expansion, scientific discoveries, and strengthening external borders. When the basics are automated, civilization has the opportunity to take giant steps forward. Order in the details allowed Rome to focus on great and ambitious goals. The modularity of the entire system made it surprisingly easy and quick to rebuild cities after any disaster. If a devastating earthquake struck or wild enemies raided a city, it was rebuilt according to the old blueprints. There was no need for lengthy discussions of new projects or debates about architectural style. The Roman system reproduced itself as efficiently as a living organism with very strong DNA. It was the ultimate victory of human order over natural chaos. The Romans themselves sincerely believed that their austere architecture was an earthly reflection of the divine order of the entire universe. For them, every straight street was a symbol of the right path in life and honesty. Solid stone walls served as a visible symbol of the protection of the law, which was the same for all citizens. The city actively educated its inhabitants by the very fact of its orderly existence. Even when the Great Rome finally fell under the onslaught of invaders, its cities did not disappear. The barbarians who captured these lands did not destroy such a convenient and well-thought-out machine for living. On the contrary, they themselves tried to settle in it and adapt it to their needs. Today, we are once again building standardized residential areas on a massive scale and opening identical chain stores all over the planet. We strive for the same comfort of absolute predictability that the Romans once created. In a sense, we are all direct descendants of Rome, even if we are completely unaware of it. Standing in a traffic jam on a perfectly straight avenue, we are repeating the path of the ancient citizens. History has come full circle and returned to the tried and tested modular standard. The Roman Empire was not just a state, but a giant construction corporation that stamped out cities like parts on a conveyor belt. This unsentimental approach provided an unprecedented level of living and stability for millions of people. Standardization, modularity, and simple but strict planning rules proved to be more effective than any creative freedom. What would you like to learn more about? Life in multi-story insulae, or how the Roman sewer system worked? Write your suggestions in the comments, and we will definitely make a separate episode about it. And of course, subscribe to the channel so you don't miss new stories about the technologies of the past.